My name is Jack, and I'm here to discuss performance, measurement and improvement in a web application context as a process and/or tool of software engineering. Performance measurement is the process of testing responsiveness, throughput, reliability and scalability under a given workload. Due to the extra time taken to measure and improve performance, the process can often be deemed as unnecessary, and on a small scale, that often is. In this talk, I hope to give an insight into the various variables that affect web application performance, some tools for performance measurement, and also look at the ways that performance can be improved. The main purpose of performance measurement and improvement in web applications is to enhance the user experience. An end user is unlikely to notice a few milliseconds of improvement, and therefore all the effort to improve the application can be deemed as a waste of time. The performance of web applications affects user experience in the time it takes for the page to load. The ultimate goal is to deliver a page to the user in the lowest possible time, but there are many variables that affect this. These include the client connection speed, server proximity to the client, the algorithmic structure of the application, and the efficiency of the platform used. First, let's have a look at one variable that we have the least control over, and that is the connection speed of the client. As a web developer, you cannot control or you cannot force your users to obtain a faster connection. You need to account for slow connections by delivering less data. An example of this being achieved is YouTube, who determine the connection speed of the client before sending each block of video. This is achieved by storing multiple copies of the same video in different quantities, split into small time blocks. The blocks are then sent to the client in a quality determined by the bandwidth of the connection. Another less sophisticated way of allowing for slower connection speeds is to deliver a completely separate version of the page specifically designed for slower connections. Now let's look at algorithmic enhancements to applications. Enhancing code to gain efficiency is something developers can spend vast amounts of time on. There can be various ways of achieving the same outcome, and some have a slight improvement to performance over others, but they can come at other expenses. Using a loop, for example, to iterate over an array, using a for loop, we'll make that, to iterate over an array can be more efficient, but that comes at a cost of readability and development time when compared to a for each loop. The platform the application is deployed on can also affect its efficiency. Java can be bloated and slow. That's when comparing it to scripting languages like Python or Ruby. Even PHP can be more efficient when compared to Java. Something else to be considered is the size of the JavaScript file that's being delivered client-side. The entire jQuery file, jQuery library make that, which is 96 kilobytes without any line breaks, doesn't need to be included for one simple animation on the page. And like jQuery, large files can be compressed just simply by removing the line breaks. Now let's have a look at some different tools for measuring the performance of web applications. A simple way of measuring performance is the use of development tools built into browsers. This can be used for measuring client-side performance, but it can be limiting as you are only testing based on your own machine and location. Now let's have a look at Chrome. So we'll open up Chrome, which is a browser. And we'll bring up the age. I'm using this just because it's there. loads. Here we go. Okay, so we find our developer tools under View. This is where also we find the JavaScript console. So now let's refresh the page and it'll bring up a timing of different elements. And this, as you can see, gives us a breakdown of what each element, the time each element takes to load. Please. Now we also have a profiler built into the browser tools. So let's have a look at that. The profiler will give us the efficiency of the JavaScript. So we'll collect some data here. Okay, and these errors seem to be from ad blocking add-ons. So we'll open this up and we can see the time taken for each element to load. Load times using machines located around the globe. This allows for client-side testing under different environments. These services include WatchMouse CheckSite as well as Monitis. As Monitis is free and doesn't take weeks to get back to you with a trial account, we should be using that for our demonstration. So let's open that up here on the computer. So this is a web-based test. Okay. So it loads. Okay. So again, we'll be testing the age from different locations. Now, this gives us 12.62 seconds of load time from the United States, 12.49 from Europe, and 15.26 from the Asia Pacific region. And again, we can see the breakdown of each element by page load time. Now we can also check specific locations in the United States with this tool. And that, oh, we've got more. We can also trace the location of where the data is travelling, and again the time it takes. Once a web application is live, the best way of measuring client-side performance is by obtaining data from actual users. Including a JavaScript program to send the user performance back to the server can do this. One drawback of measuring data this way is that the measurement tool needs to be sent to the client for each page, and it can add to the size of the application. This can slightly affect the performance. I have found a program written by Zach Bloom for this demonstration. So we have the files here located on GitHub, and here we can see that it is all there. Okay, so this is stating just how to set it up. And it means that the JavaScript file is embedded in each page. Now here we set a host of where to return the data to. This is usually another graphing application. He suggests using an application called Graphite, which enables you to show the data as a graph. The final tool I have to show you is Wireshark. This is a tool for analysing network packets and can be used for testing the connection. So let's have a look at Wireshark. So we capture an interface. In this case, it'll be our Wi-Fi. And we hit start. This will bring us details of every packet moving through the network. Now we want to just narrow this down to the HTTP. Now let's open up a web page. And close a few of these windows just to make sure we're only analysing the exact page we want to analyse. So again, let's use the age. We open up the age, and we can see all these packets coming in. We can also see the time that it's taken to receive these packets. And we'll try another page. And we get more packets here. Now, try this again from the beginning, just to give us a clean slate. And we'll go back to the main page of the Age. Refresh that, clear the cache, and here we go. Here's everything coming in from the site. Now we can also see what's in these packets, and this gives us a bit more detail. Performance can be measured and enhanced for web applications using a variety of tools. This evening I have focused on the client side of web applications. There are other tools such as Perf for profiling applications, but this is something that other members of my team have looked into. So if you want to learn about that, you should probably watch their videos. Another aspect I haven't looked at is looking at the hardware performance. This is also something that can affect a web application, though increasingly less with the increased use of cloud services for hosting. Hardware performance is also something that I believe other members of my group have looked into. So again, if you want to look at that, you should watch theirs. Thank you for watching. And as a reward, I now leave you with this footage of 2 guinea pigs eating a banana. Don't need your breathing, don't need your pain.